Hey guys, thanks for checking out this video. Today I'm going to be showing you guys how I run a layer adhesion test using entirely 3D printed materials. First thing is my pull force gauge, which will tell you what the maximum amount of force exerted is with a nifty little readout. This thing can be found on Thingiverse right here. That's the thing number. So I'm going to go ahead and make sure that my spring, any deformation is taken out because I used PLA for the spring. We're going to hope that the small amount is enough. Okay, so what we're going to be doing today, pretty straightforward. We're going to be measuring the amount of pull force for each one of these little keys to snap off. We're going to be hooking the pull force gauge on. This is a 1-inch distance. This is a 2-inch distance. I think the 1-inch will do everything, but basically what we want to do is measure the amount of force it takes to snap this guy off right at the base there. Super simple device. The keys are labeled 200C 0.1 millimeter. So I have 6 of them, and I've sliced them according to what they're labeled with. So it's very straightforward to keep them separate, and then we'll be entering the results in a good old-fashioned spreadsheet, like the data scientists that we are. So all we need to do is measure the snap force. For example, I'm going to make sure that I'm good and equalized. I want consistent spring force every time. So if there's any deformation in the spring, I want to take it out now, not have it come out on the first few pulls. So all we're going to do is take our cool little force gauge. We're going to measure the brake force. Is that 2? I call that 2.5 for 200C 0.1 millimeter layers. 200C 0.1. So 200.1. We've got a 2.5. Punch that in the spreadsheet. Now let's do 210C 0.1. Slide our meter back to 0. Okay. Look at that, 2.75, I'd say. Right between the... Now there are 5 marks. There are marks of 2. So we're looking at 2, 4, 6. Let's call it 0.7. Let's call it 2.7. Okay. Zero that. And let's try 220C. Oh, that's about 3.1. It's right at the left edge. So we're going to call that 3.1. You see where 0 is, right at the left edge there? So, right. Okay. Now let's go to the 0.2 millimeter layers. Zero our slider out. Ooh, this one's strong at 0.2 millimeter layers. We have, that's 2.5. Same as the 0.1, that never happens. 2.5. All right. 210C 0.2. I'm going to call that 2.15. Not quite 2.2. Okay, we have one more to measure. I'm not sure if this one got misprinted or not. We're going to find out. That's 2.0. This is interesting data. Okay, I'm going to plot this up and I'll show you. Okay.
A few moments later.
Okay guys, as promised, we have a data workup because we love our data. And I'm going to kind of zoom in if I can with the tripod. And we have a fantastic result. If we are running a thinner layer, this stuff really likes heat. Apparently it wants a stronger weld. If we're running thicker layers, heat is actually giving us a weaker part. So we should be running this a little bit cooler for stronger weld, or for an overall stronger part. Apparently, maybe running it hotter makes the actual extruded filament weaker. I'm not exactly sure, but this is an interesting result. So if I was to use this filament, now I know if I want to run thin layers, run it hot. If I want to run thick layers, run it cold. This is why you take your data. Now I know exactly how to drive this filament. So that's what my layer adhesion test rig does. That's how easy it is to use. 100% 3D printed. Print the keys, print the handle, print the pull force gauge, go to town, figure out how to make the strongest possible prints you can. No cost to you, just print the parts and use it. Enjoy. Hopefully this helps you. And if you like it, maybe I'll make some more videos.